In the previous videos, you have seen that how to configure all three streaming methods of gRPC in both Proto-C and server-side code. Now let's see how gRPC streamings are seen in the client side and then demo all kinds of streaming in the Java project we have set up.
Now let's move on to coding. So you have already seen this implementation. Now what we need to do for the other streaming implementation is that we need to create a non-blocking stub. So till now we have been working with the blocking stubs, that is, pure simple request and response. Now we need to create a non-blocking stub. So I'll again go here, student service gRPC dot student service. There should be a non-blocking, I think, yeah. So student service stub is the non-blocking stub is equal to student service gRPC new stub, and I can give this managed channel. And then what I need to do is that I need to have a non-blocking stub dot. First of all, let's have a server-side streaming. So it takes two things, student request and student response. So what we can do is that we can have a student request again as student request dot new builder dot build. And what is the response? So if you see here, the definition is response observer. So we need to create an object of type response observer, new stream observer. So let's create that new stream observer. And these are the methods we need to implement on observing the response. So in the client side, we were observing the request, and in the server side, we are just observing the response. So now we'll just have a student response. So we can log, or we can act on the response from the server. So it will be response from the server is equal to plus student response dot get name plus student response dot get age. So this is the response. We can have a logging on the error as well as the completion method. So this is how the server side streaming will work, like that. You make a request, and then what you have is the response. So you just register the events that from here the server side streaming request will be made, and then the hooks are registered accordingly. So yes, so this is the non-blocking server side streaming. Now we'll move on to the client side streaming. So what do you do when you stream from client? That is, you want to upload something. So for that, what we need to do is that we need to call a method called server side streaming, the client side streaming. So what we'll do is client side streaming. So if we see, what does it take is the parameter is a observer, student response observer. So we need to have this particular definition in our code. So what we can do is stream observer student response stream observer new and we can pass this here. So I can pass this in my parameter like this, okay, and I can actually, and what does it return? It returns the stream observer student student request. Okay, so these are the things which get registered. So now if I want to have a client-side streaming, what I can have is the simple on next method, that is what's the response from the server. So here I can have a response from the server equal to plus student response dot get age plus student response dot get name, and these are the errors and the completion things. And here, so this one is pretty obvious that you get one response from the server, so this is what you will get, that is the response. And the likewise you can have the streaming stuffs. And this stream observer, what you can have is that you can send multiple requests from the client. So you can have even like for int I equal to 0, I less than 50, I plus plus, and you can send the multiple requests to the server. So basically if you do this student request dot new builder dot build, so it will send multiple requests to the server, and then once you are done you can do the on completed. So in this way what you are going to do is that you are going to send multiple requests to the server, and those requests are going to be sent in a stream, and the server is just going to process those stream one by one. And the fourth one and the last one is the bidirectional streaming. So for the bidirectional streaming, what we need to do is, if you see non-blocking storage or bidirectional streaming, it has the same syntax as the the server side, the client side streaming. So I just need to copy this. I will declare the same observer one, I can name it as this, and I can have a student responsive one. I'm just copying it for the sake of later I should be able to refactor the code. And here what I can have is the same stream response observer. So at the client side you see the syntax is pretty much the same, and then I can have for int I equal to 0, I less than 100, I plus plus, and I can have student response dot on next, and then I can send a student request dot build, and eventually I can have a student stream observer one dot on completed.
So this is the server side or bidirectional streaming, where you are streaming from the both side, and you saw that this code is same as the previous code. So what's the difference? The difference is in the server side code. So if you go to this server side code, and here you will see that in the client side streaming on next you can't send any response. So for example, here in the bidirectional streaming you can even stream from the server whenever you get a request, whereas in the client side streaming you can't do that. If you do that you will get the error. So that's a minor difference. In case of bidirectional streaming, the code in the client side is same as the previous code. So here in the client side you see this code and the other code was same, but here they are different. So this is how all the 4 streamings are working. Now let's do one thing. We have already coded all the 4 streaming, but of course it will get cluttered and the logs would be in a way that you might not be able to understand what exactly is happening. So here let's do one thing, that let's add them in separate methods. So let's do that, the blocking code to be in one method and likewise the non-blocking to be in the other one. So I can extract this method. So there are a bunch of good methods where you can extract. So I can name it blocking, or we can say no streaming. Okay, so this is for no streaming. Okay, coming to, okay, it might be the static method, anyway, nobody cares. The other is for the non-blocking. So this is for the server side streaming. So we'll have the server side methods here. So this is for the non-blocking in this way. And this will be the client side streaming. So we can extract this code block into the client side streaming. And this code block is for bidirectional streaming. So that at least we know what we are doing. So it will become easier for us. And let's move the declaration of block stubs here. And we'll do one thing. We'll do one more thing, that we'll have scanner. We'll take the input from the console to check the streaming, and we can have scanner dot next int next and choice. So I'm doing this so that we can run the code in the console itself. So I can have while choice is not equal to -1. We can enter one for no streaming, 2 for server streaming, 3 for client streaming, and 4 for bidirectional streaming. And then we can have a do while. That will be better actually. Do while choice is not equal to -1. And here we can have choice, and then we can have switch choice. Case 1 we can call no streaming, manage and break. Case 2 server side streaming, non-blocking stuff, break. Case 3 I can have a client side streaming, non-blocking stuff, break. And case 4, again a bidirectional streaming, non-blocking, stop, and then again break. And by default okay, we won't do anything here. We'll just keep on asking the same question if while the choice don't match. And okay, we can have in choice equal to -1. Okay, so for -1 means that you can exit, and we can remove this code from here. So it's a plain simple do while code which will opt in for one of the streaming methods so that we can demo. So now the setup is ready. You can see that we have a console application for the client side. We already built the server side application for various kinds of streaming, and now it's the time for demo, where we'll see all the streamings one by one so that we can see and feel how these streamings are working. So for that, the first thing to do is to start the server. So I have already built the server in the previous video. You can run the server using public static void main. You can see that the server has started. Now coming to the client side, and what we'll do, we'll run this method. Okay, so here it's asking for 1 or 2, so let's start with 1. So for 1, the response came to be just one response, that is, no streaming. So in this case, the method with the call which was made was this. The blocking call was made to the server, and the server, if you see the code of the server, it just got one request, it gave the response. So one request, one response, the plain old HTTP method communication, where you make a request, you are blocked for the duration, and then you get a response. So simple plain request and response method. Now let's enter 2. So for 2, what will happen? If you see the server side streaming, in this case, this method will be called once. That is, a client will make just one request, and the server will return multiple responses. So this is a server side streaming. So for example, I make a call to download a file. So here I will make just one request from the client side, and then the server will give me the response. So you see, just one request and all the response. There is no on next method or anything like that, which would get called. Here the communication is made to the on next method of the client. So if you see the server side streaming, so here the code is that it just makes one call, and then on next, these are the responses which it will get. So let's come here and write the run for 2, that is the server side streaming. See, you see so many responses are just keep on coming. It is not that the client is waiting for all the responses. You can see in the loop of, I think 10,000 I set or 1 lakh, the responses just keep on coming one by one. So it is not that my client is waiting for 100 seconds. So this is the classical example of the streaming, where you see that the responses are just keep on pouring in, and there are so many responses that you will have to wait for all the responses to come. So what I'll do is I'll pause the recording and then connect again, because I have set a larger value and the screen recording is also going on. So let me pause and then run the client side streaming. Alright folks, so I pause my server, and let me pause here and go into the server and decrease the number of responses here. So I'll make it 10, and then I will run my server again. So here is my server. I'll go and run the server, and then let me go and run the client as well. So the client was running earlier, I stopped the client as well. and let me go here and run the client. So again, here it will ask me to enter one of the three values. Let me enter the value 2, that is the server side streaming. So here you see 10 responses from the server, one by one. So all of these have different timestamps and none of them is blocked for all the 10 responses. So this is the advantage you have compared to HTTP, where the server is able to stream the data to the client. So this is how it works for the streaming part. And now let's run for the third use case, that is the client side streaming. So I'll run the client again now, and here is the client code. So if I enter the 3, so you can see that we sent the multiple data to the server. So if you go to the server, you will be able to see, so let's go here, this is the server code. So you see multiple requests received to the server. So if I just clear it up, clear all, and I go to the client, and let me pause it again. So there is one on completion method which you need to set so that the loop can run and the program counter can come back, but I don't want to cover it. I'll cover it later, or I'll see. I want to have this video simple and just focus on the streaming part. So let me run this code again for the client, for the server side streaming. So I have entered the 3, that is the client side streaming, and if you see this server code, it's blank. Now I entered this 3, and you see that server will receive the request one by one. So this is the client side streaming, where client is sending the data one by one and the server is receiving the data. So this is how the client side streaming works. And the final is the both side streaming, that is the bidirectional streaming. So here I'll run my client again, and I will clear my server. So I'll go here, I'll clear all so that you can see what is happening here, and I'll have a bidirectional streaming. So here you will see that you are getting the response from the server as well as you are sending the data. So you are sending the data to the server, and as well as you are getting the response from the server. So to and fro, both the things are happening, and both the things are asynchronous. So basically you are sending the request and you see got the request, sending the response. So these things are happening, and they are not dependent upon each other, and the streaming is working both ways. So this is the last type of streaming which is happening. So you can see the all 4 kinds of streaming can be done using gRPC, and this is the one of the most important reasons why you would choose gRPC over HTTP. That is, now you are not blocked, you can stream the data from one side to other, and in fact that is efficient as well, because here you are using HTTP 2 by default. So both the things are there, and yeah, I found it quite interesting, and please try this video. So that's my advice, that especially the demo part of this video will give you a sense that why gRPC is important, and how it can help you to send a bigger chunk of data. And yeah, do like and comment to this video if you like it, and let me know what else would you like to understand about this topic or any other computer science topic. I'll keep on posting such videos every week. Till next time, bye.